So now we're going to look at ternary ionic compounds. So remember that ternary means that we're going to have 3 or more different elements. So the directions say to underline or circle the polyatomic ions. So I've already done that part for you. You can identify the polyatomic ions using your reference table. Remember, there's a list of polyatomic ions on the back of the reference tables. So here you have sulfate, chlorate, ammonium, and hydroxide in the same compound, carbonate, sulfate. Over here you have hydroxide, nitrate, hydroxide, carbonate, and then hydroxide again. I'm going to start first with writing formulas and naming compounds for main group metals only. I'll save the transition metals for a different video. So when you look at the periodic table, you can identify potassium as a main group metal because it's in group 1. So let's start with the flowchart. It says, does the compound contain a metal? And the answer for number 2 is yes. Then we move on and it says, is the metal a transition metal? Well, you'll be able to answer no because once again, potassium is in group 1. Now looking at this, if you count the different elements in this compound, you have 3 different elements. That lets us know we have a ternary compound. So when you have a ternary compound, it does contain a polyatomic ion. So 3 or more capital letters, K, C, and O. 3 or more capital letters lets us know we have a ternary compound. So you're going to name the metal first, which is potassium. Then you're going to name the polyatomic ion. The polyatomic ion here is chlorate. All right, let's look at number 4. Again, does the compound contain a metal? Yes. Is potassium a transition metal? No. Is it a ternary compound? Yes, because it contains a polyatomic ion. We have 3 capital letters. So we are going to name the metal first. So again, we have potassium. And now let's name the polyatomic ion carbonate. Looking at our next example, following the same rules, I won't read the steps on the flowchart for you. You can pause and do that yourself. We have sodium, and then you can look at the periodic table, at the reference table and identify sulfate as your polyatomic ion. So that compound is sodium sulfate. Looking over here, again, we're just going to look at main group metals for the moment. So now, going to your periodic table, you'll see, I'm going to work up here, that sodium has a charge of +1. Look at the reference table, you'll see the hydroxide has a charge of -1. Remember we discussed in class that we keep polyatomic ions together, the atoms rather, and polyatomic ions together. When you look at the formula for hydroxide, you see that there's a 1-to-1 ratio, and we need to respect that, so we cannot change anything about that formula. So we crisscross our numbers or our charges, remembering that we don't write numbers and our charges cancel. So now we have the formula NaOH. All right, looking at our next example, sodium nitrate. Sodium is a main group metal. Sodium has a charge of +1. Nitrate, when you look at the period, at the reference tables, nitrate's formula is NO3 with a charge of -1. Again, remember, you cannot change anything about this formula. In the formula for this polyatomic ion, there's 1 nitrogen atom to 3 oxygen. So we're going to crisscross our charges. Remember, we don't write ones. We drop the charges, and your formula is NaNO3. Looking at our next example, we have barium hydroxide. Looking at the periodic table, barium is in group 2 as a charge of +2. Looking at the reference table, you'll see the hydroxide has a charge of -1. Again, this entire ion has a charge of -1. We cannot change anything about that. And maybe it will help to put your polyatomic ion in a box. So when we cross the numbers and drop the charges, the 2 comes down here, and our 1 crosses over, but we don't write ones. Since this subscript is greater than 1, we need to make sure that we put parentheses around the polyatomic ion. So then your formula becomes BaOH2. Because if you look inside the parentheses, there's a 1-to-1 ratio between the oxygen and the hydrogen. Looking at the next example, calcium carbonate. Calcium has a charge of +2. Carbonate has a charge of -2. A +2 and a -2, that's a 1-to-1 ratio between charges. We need 1 calcium ion to balance a 1 carbonate ion. So those reduce. If we divide both numbers by 2, you get a +1 and a -1. So we can cross those charges, and then our final formula becomes CaCO3. All right, so now let's go back and look at naming compounds that contain 2 polyatomic ions. So again, this is a ternary compound because it does contain a polyatomic ion, not just 1 but 2 polyatomic ions. And we have 3 or more capital letters. So we first name this first polyatomic ion, which is ammonium. And we're going to name the second polyatomic ion hydroxide.